In this lecture, we are going to write our own computer program to multiply two given matrices. So first of all, we'll start by building our own logic for matrix multiplication. Okay, so let's get started. So let's say you are supposed to multiply two given matrices. You are given a matrix, right? So matrix is nothing but a 2D array, right? So it has rows and columns. So let's say you are given two matrices. It's given here, shown here in the example number 1. Okay, the first matrix is having 2 rows and 3 columns, and the second matrix is having 3 rows and 3 columns. Okay, so this is 2 by 3 matrix. Matrix A is 2 by 3, and matrix B is of dimension 3 cross 3. Now in order to multiply these two matrices, okay, first of all you will catch hold of the first row of matrix A. So in the first row there are 3 elements, 1, 2 and 3. So for the size of first row is 3. So there are 3 number of columns in the first matrix, and this 3 elements will be multiplied with the corresponding elements of the first column of second matrix B. So in the second matrix there are values 1, 4 and 7. So there are 3 elements in the column of matrix B. Now in order to multiply matrix A and matrix B, the number of columns in the matrix A, that is 3, should be equals to the number of row in the matrix B, that is also 3. So whenever number of column in the first matrix is equals to number of row in the second matrix, then you say that the matrix multiplication is compatible. That means now you can actually multiply these two matrices because the corresponding elements are matching in the size. Now let's take one more example, example number 2. In example number 2, matrix A is of having number of columns as 3 and matrix B is having number of rows as 2. In this case, if you see, column of the first matrix is not equals to the row of the second matrix, right? So in this case we say that the matrix multiplication is incompatible because there is a mismatch in the dimension. In the first matrix there are 3 elements here, and here there are 2 elements, so there is a mismatch, therefore you cannot multiply these two matrices. So whenever you start performing matrix multiplication, the first thing that you need to check is for compatibility. The matrix multiplication is compatible only if the column size of the first matrix is equals to the row size of the second matrix as shown in example 1. In all other cases, you cannot multiply those two matrices. So this is the first thing you should know regarding matrix multiplication, that is compatibility. Now let's try to multiply these two matrices A and B to get the resultant matrix C. A is a matrix of dimension 2 cross 3, 2 rows and 3 columns. B is a matrix of dimension 3 cross 3, that is 3 rows and 3 columns. So first of all, now you check for compatibility. So first of all, you see the number of columns in the first matrix is 3, right? Number of columns in the first matrix is 3, okay? And number of rows in the second matrix is 3. So 3 is equals to 3, that means it is compatible. So you can actually multiply these two matrices to get the resultant matrix C. Now what would be the dimension of the resultant matrix C? The row dimension of the resultant matrix C would be row 1, that is the number of rows of the matrix A, that is 2 cross the number of columns in the resultant matrix C would be the column of the matrix B, that is column 2, which is nothing but 3. So the dimension of the matrix C would be 2 cross 3. So let's say this is a matrix C, so this is of dimension 2 cross 3. Okay, so this is my resultant matrix C. Now how do I perform the multiplication is very simple. First of all, you will go to the matrix A and catch hold of the first row indexed by index I equals to 0. So there are 3 elements, 1, 2 and 3, and then you will catch hold of the first column in the matrix B, which is indexed by index 0. And then now you are going to multiply the corresponding elements for the selection that we have made, right? So first of all, you will multiply 1 with 1, so it will be 1 times 1 plus, okay, then you will multiply 2 with 4, 2 times 4, then you will add that with the product of 3 times 7. So corresponding multiplication, you will do it like this. Okay, now once you are done with the first column of the matrix B, you will go to the next column of the matrix B, and the row of the matrix A is kept the same. So the row is 1, 2, 3, and now the new column that you are taking care of is 2, 5, 8. So you do the corresponding multiplication. So you will write 1 times 2 plus 2 times 5 plus 3 times 8. Okay, so corresponding multiplication you are done. Okay, now what you do is, once you are done with the second column of the matrix B, you will move to the last column, right, indexed by 2. Okay, and the row you keep the same in the matrix A, the first row, that is having the elements 1 2 3. So you multiply 1 2 3 with 3 6 9, corresponding elements are multiplied. So you multiply first of all 1 with 3, then add that with 2 times 6, and add that finally with 3 times 9. Okay, so these are the three elements of the first row in my resultant matrix. Now I'll have to fill up the second row of the resultant matrix. Okay, now what I do is I'll go to the next row of my matrix A. Okay, so I go to the index 1 and then I select the elements 4 5 6. Okay, and now in matrix B I'll select the first column. Okay, that is again indexed by 0. There are three elements 1 4 and 7. I make the corresponding multiplication. So I'll write 4 times 1 plus 5 times 4 plus 6 times 7. Okay, corresponding elements are multiplied. Okay, so what comes here at index 1 1 of the resultant matrix is you have already selected the second row 4 5 6 of the matrix A, and now you select the second column of matrix B at index 1. So 2 5 8 are the elements. So you multiply 4 5 6 with 2 5 8 corresponding elements. Okay, so I'll write 4 times 2 plus 5 times 5 plus 3 times 8. Okay, so this is how you do the multiplication. Now finally the last element for the resultant matrix you'll find out by multiplying the second row of matrix A, that is 4 5 6, with the third column of matrix B, that is 3 6 9. Corresponding elements are multiplied. So you'll write 4 times 3 plus 5 times 6 plus 6 times 9. Okay, so this is the multiplication that you perform. Here we have done a little mistake. Here instead of this 3 it should be actually 6 times 8. Okay, so this is 6 times 8. Okay, so this is the correction that we are making here. Now if you multiply this, we'll get the answer. Let's write down the resultant matrix by doing the product of all these values, and let's see what is the answer. Okay, so this is my resultant matrix. Okay, there are 6 elements, 2 rows and 3 columns. The elements are 30 36 42 66 81 and 96. So this is the matrix that you are supposed to display finally given the matrix A and the matrix B. So I hope you have understood how matrix multiplication actually works. This is just an example. Now we are going to build our own logic for performing the matrix multiplication. Alright, so first of all our objective is to generate this resultant matrix C. Now we are aware that in the resultant matrix there are 2 rows and 3 columns. So in order to generate each of these elements I need to run a loop. 2 loops, one loop for taking care of my row and one loop for taking care of my column, right? So for my loop, let's write down the loop here for, okay, so I'm just talking about the resultant matrix C, which has 2 rows and 3 columns. So I'll run a loop, I indicating my row. I starts from 0 and I goes up to 2, so it will go up to less than 2. Why 2? Because there are 2 number of rows. So there's index 0, so initially I is 0, and for the next time I would be 1. Okay, so I less than 2, I plus plus. This will take care of the rows of the resultant matrix C. Okay, and then I'll have to write a loop to take care of the column of the resultant matrix. There are 3 columns, column index j equals to 0, j equals to 1, j equals to 2, right? So there are 3 columns, so I'll write the j loop here. J starts from 0, okay, j less than, what is the column size? 3, and then j plus plus. Now this is my inner loop that takes care of each column in my resultant matrix. Okay, so I hope this is clear. So now let's try to make this loop more generic. So how did I get this 2 here and 3 here? 2 is number of rows in the resultant matrix, right? So number of rows, how did I get this number of rows? Number of rows in the resultant matrix is number of rows in the first matrix, right? So this we call it as row 1. This is row 1. Okay, so instead of 2 now I can write row 1 because this is nothing but row 1. So I'll just replace this 2 by row 1. So I'll write here I less than row 1 because row 1 in this case is 2. Okay, and then obviously I plus plus is there. So this is now more generic. Okay, and now how did I get this 3? 3 is nothing but number of columns, right? Number of columns in the resultant matrix. Number of columns in the resultant matrix is nothing but number of columns in the matrix B. Okay, this is call 2, col2. Okay, so instead of 3 I need to write col2, which is number of columns in matrix B. So this is col2. Now these two loops have become more generic. It works with all sort of matrices provided that matrices are compatible for multiplication. We have not written down a code for checking that compatibility right now. While implementing it, we are going to do that. And then we have also not written down the code for taking the input for the matrix A and the matrix B. That also we are going to do it while implementing it. Here we are just focused on building the logic for doing the matrix multiplication. Alright. So once this loop is done, now we need to write a code to somehow get this element. Okay, how do I get this particular element? Okay, now to get this particular element at index 0 0 of the resultant matrix C, okay, here I'll be placing an element here, right? But this is nothing but the series of additions I'm doing additions 3 times. 1 times 1 plus 2 times 4 plus 3 times 7. Okay, so if I'm adding things together, initially let me assume that there is a variable called as sum, right? And sum is initialized to 0. I'm making sum as 0 because initially I'm assuming that this entire thing is 0. Okay, now first of all I'll add 1 times 1 to this sum, and then I'll add 2 times 4 to this sum, and then I'll add 3 times 7 to this sum. Okay, so let's do that. Now how did I get this 1 time 1? So whenever I'm trying to get the answer for this particular place, that is C0 0, I'm trying to get the answer for C0 0, right? In that case I'll catch hold of the first row of the matrix A and the first column of matrix B, right? The index of the first row of the matrix A is I equals to 0, and index of the first column of matrix B is nothing but J is equals to 0. Okay, so I equals to 0 will catch hold of the first row of my matrix A, and J equals to 0 will catch hold of the first column of matrix B. Okay, so to get C0 0, first of all what I do is I multiply 1 with 1. So this multiplication, this is nothing but A0 0, A0 0 is 1 times B0 0, right? B0 0 is also 1, so 1 times 1 becomes 1. Then I'll add that with 2 and 4. Okay, so the product of 2 and 4. So first of all, how do I get 2 is nothing but A01, A01, and how do I get this 4? 4 is nothing but B10. And then finally I'll have to multiply 3 with 7. How do I get 3? Okay, 3 in matrix A is nothing but A02. A02 is 3, and I'll multiply that with B20. B20 is nothing but 7. So these are the series of multiplication I do, and then I'll have to finally add and get the values. Now if you look at this, I'm multiplying each element of A with B. Okay, in this example, if you see, in matrix A, I'm already catching hold of the index I equals to 0. So if you see, this is I0, this is I0, this is I0. That is, the row index is fixed, right? So if I have to do the generic multiplication, I'll write A, 2 subscripts are there, multiplied by B, some 2 subscripts are there. So the first subscript here is I, and this is fixed, right? For the first iteration, I is 0, so it is 0 0 0 everywhere, right? Similarly, in matrix B, if you see, the column is fixed in matrix B. In matrix B, you see this is 0, and this is 0. This column is fixed, so I can write J here because this is fixed, right? Whenever J is 0, I'm just catching hold of this particular column, 1, 4, and 7. Now if you see in the fixed row of the matrix A, so here I equals to 0, the first row is fixed. There are 3 elements, right? 1, 2, and 3. So I need to have one more loop, let's say K loop, to catch hold of all these 3 elements one by one. Similarly, in the second matrix, J is fixed. That means the column is fixed. There are 3 elements. Currently J is 0. So these 3 elements are, 1, 4, and 7. So to take care of that, again I need to have a loop here, K loop. Right? So K would be 0, K would be 1, K would be 2. In this case, here also K would be 0, K would be 1, K would be 2. If you see here in the multiplication, this is K because this is 0, 1, 2 number of columns in the matrix A, and this is 0, 1, 2 which is number of rows in matrix B. Now this is, you see, 3 and 3, they are same. So this is my K. Okay, so this is my K. So here I'll write K. Okay, so I need to run a loop here, K loop. Okay, so I need to run a loop here, that is K loop. So I'll write for K equals to 0, K starts from 0, and K is less than 3 in this example, K plus plus. Now K is 3 here. 3 is nothing but number of columns in matrix A or number of rows in matrix B. So I can write or make it more generic here. So here I can write 3 instead of 3. I can write column 1, or I can also write, instead of column 1, I can write row 2 also, right? Because column 1 and row 2 are the same. Now what do I do in the innermost loop is very simple. I need to do this multiplication one by one. So I'll have to multiply and put that product in a sum variable. So initially sum was 0. So I'll write my new sum would be previous sum, whatever it was. Okay. Plus I'll go to the matrix A at index I and K, IK, this is IK, times, I'll go to matrix B, the element at index K, row index K, and the column index J. Okay, I'll do this multiplication. Now once this K loop is over, I'll get my sum, right? Sum would be nothing but this sum. So I'll be storing this sum in the index 0, 0 of my resultant matrix C. So I'll write, after this loop, C, I, J, at index ij, I'll be storing the value sum, right? So once I store the value in this particular index C0, 0, what happens is it will go and update the value of J. Now J becomes 1, right? Now J becomes 1. J is 1 and I is still 0. So I'm trying to find out this value. Now to find out this value, what do I do is J is 1, right? So whenever J is 1 and I equals to 0, what does it mean is I0 means I'll catch hold of the first row of my matrix A, and J equals to 1 indicates that I'll catch hold of the second column of matrix B, that is the column indexed with J equals to 1. So this is J1, okay, and here this is I equals to 1. So now I'm catching hold of this row in the matrix A and this column in the matrix B, and then I'll initialize the sum as 0. Okay, then I'll run this K loop. Okay, K loop will make sure that I'll get these three sums one by one. I'll add it to the sum variable and then store that value back in the C0, 1. So this is done. So similarly, now I'll move to the next index, then next index and next index, and so on and so forth. Finally, I'll be getting my resultant matrix. So this is the core logic for actually performing the matrix multiplication. I hope this is clear. Now we're going to write down a code to demonstrate the same. So this is the program to multiply two matrices. We have already started by writing some of the functions. So first of all, I'm starting by writing a function to display the matrix, because I'll be displaying the matrix many times. So displaying the matrix is put here in the function. Okay. So this function simply takes a matrix mat, and it takes number of rows and number of columns and displays this matrix using two loops here. Okay, in a matrix form. It will be displayed in the matrix form. Okay, so this is a very simple function, and then this is the main function wherein we'll be doing our code. Okay, so first of all, these are three matrices that we are working with. Matrix A is the first matrix, matrix B is the second matrix, and matrix C is my third matrix. These are integer matrices, each of dimension max times max. Max number of rows and max number of columns is available in this matrix for use. Okay, max is already defined here using hash defined symbolic constant, which is initialized to 10 initially. And these are the dimension of matrix A. Matrix A is having the dimension row 1, column 1. Matrix B is of having the dimension row 2, column 2. And I, J and K are loop variables, variable for taking care of our loops. Okay, so first of all, what I do is I'll take the dimension of the matrix A. So dimension of matrix A is scanned here, that is row 1 and column 1. And here I am scanning the dimension of matrix B, that is row 2 and column 2. Now before I actually take the input for the matrices, what I do is I'll check if they are compatible for multiplication. So how do I check for compatibility is, if the column of the first matrix, that is if column 1 is equals to the row of the second matrix, row 2, if column 1 is equals to row 2, that means they are compatible for multiplication. So here I'm going to take the input for the matrix A. So I'll display the message here, printf enter your matrix A. Okay, how many values are there? So there are %d elements in matrix A. So what is %d? In matrix A there are row 1 number of rows and col 1 number of columns. So I'll write row 1 times col 1 number of elements. Please enter. Okay, so I'll have to run a loop here for I equals to 0. I is taking care of my row. I less than, how many rows are there? Row 1. So less than row 1, I plus plus. This will take care of my row. And here I'll take care of my column for j equals to 0, j less than, what is it? Column size is column 1, less than column 1, j plus plus. Okay, here I'll have to write the scanf to scan the elements. So I'll write here inside the inner loop, I'll write scanf %d, and then here I'll write ampersand. I am talking about the matrix A. In index I and index j, I'll be scanning the value, right? So this will make sure that my input is taken, right? Now once this is done, I'll do the same thing. I'll repeat the same thing. I'll just copy this code, repeat the same thing for matrix B as well. Okay, so I'll write here enter your matrix B. Okay, so matrix B is of what dimension? It is of dimension row 2, column 2. So I'll change it here. number of elements is row 2 times column 2. These many elements please enter. I'm giving a message. So here number of rows I'll change it to row 2 and number of columns I'll change it to column 2, and this matrix A needs to be changed. It should be B. I'm taking the input for matrix B. Now I've taken my input. Okay, now let's try to test if our output is working fine. So I'll write printf matrix A is, I'll just print this matrix A. Okay, how do I display the matrix A? I've already have this function display matrix. Okay, display matrix is already defined here. It takes 3 arguments, the matrix, row and the column size. Okay, so the matrix A is the name of the matrix, row size is row 1 and column size is column 1. Okay, this is how I display the first matrix A. Okay, now I'll just copy this and do the same thing for matrix B also. Okay, so I'll paste it here. So here I'll write matrix B. Matrix B is nothing but I'll display the matrix by passing the matrix, that is B, and the row of matrix B is row 2 and column is column 2. Okay, now let's try to see if it works fine. Okay, here we have not done the complete code for multiplying the matrices. Okay, what we are following is we are again following the principle of code a little, test a little. We have done a little bit of our code, little portion is done. We are testing it first before we move on. Okay, matmul.c compilation. Let's see what happens. Compilation successful. e.exe. Let's say number of rows is 2, number of columns is 3, and here number of rows is 3 and number of columns is 3. Okay, so they are compatible. So it is asking me to enter 6 elements of the first matrix A. So I'll write 1 2 3 4 5 6. This is fine. 9 elements of matrix B, 1 2 3 4 5 6 7 8 9, and it shows me the matrix that is printed correctly. Okay, so this is working fine. Now we'll write our logic for multiplying two matrices. So we are supposed to generate the matrix C, right? So I'll have a loop because matrix C is my resultant matrix is having row 1 number of rows and col 2 number of columns. So I'll have to run a loop here for I equals to 0. I less than how many rows are there? Row 1 number of rows are there. Okay, I plus plus. And this is my number of rows in the resultant matrix. So this is my number of columns in the resultant matrix. J equals to 0. J less than how many columns are there? Col 2 and J plus plus. Okay, so this will take care of my rows and columns in the resultant matrix. Now as you have already discussed the course, first of all I'll have to initialize the sum as 0 because I'm trying to find out the element at the index ij of the resultant matrix, right? So initially the sum is 0. I'll keep on adding the values to this sum, so I'll have to declare this variable sum here. Okay, so I'll write int sum. Okay, so this sum variable is also declared here. Now sum is 0, so I have to run a k loop here for k equals to 0, k less than col 1. I can add col 1 or row 2, both are same, so I can add anything, right? K plus plus. Now inside this I'll write my sum would be nothing but previous sum plus I'll multiply the corresponding element of matrix A and matrix B. So I'll write A I k times B in the matrix B k j. Okay, this is what I multiply, and I keep on multiplying this, and sum is calculated. Once sum is calculated, I'll have to store this sum in the matrix C at index ij. So I j at C ij I'll store this sum. Okay, so this will keep on running in a loop. There are 3 loops running here. Okay, and once everything is done, it should be working fine and my resultant matrix should be ready, right? So once this outer loop is done, my logic for multiplying the matrix is done. So here I'll have to display my resultant matrix C. So I'll just copy this here for displaying the matrix, the code for displaying the matrix. So I'll write matrix C is nothing but the product of A and B is nothing but display matrix. Which matrix I'm trying to display? I'm trying to display the matrix C. What is the number of rows of matrix C? Matrix C, number of rows is row 1 and number of columns is column 2. Row 1, column 2, right? So let's try to see if it works fine. Let's try to compile this code once and then see if it works fine. Okay, so compilation is done here, no error, right? Now let's try to give some input and see if it works fine. Okay, let's give the same input that we had discussed before. 2 rows 3 columns in the first matrix, 3 rows 3 columns in the second matrix. It is compatible, so I'll give the values 1 2 3 4 5 6. So matrix 1 is entered, 1 2 3 4 5 6 7 8 9. Matrix 2 is entered, and you see the product matrix C is nothing but 30 36 42 66 81 and 96, the same answer that we had already done. Okay, now let's try a code wherein the matrix is not compatible. Okay, let me write the matrix 2 cross 3 and let me give 4 cross 3. Okay, it says nothing is being displayed because it is not compatible, right? So if it is not compatible, let me try to display that it is not compatible, right? If column 1 equals to row 2, it is compatible, and then I'm actually taking the matrix. But if it is not compatible, I'll come to the else part. Okay, so here I'll write else. Okay, else what do is I'll enter, and then here I'll write printf it's not compatible for multiplication. I'll just give this message here, okay, so that the user comes to know that it is not compatible for multiplication. Compile this code one more time and then run it. So I write 2 cross 3 and 6 cross 3. So this is not compatible, so it is giving me the output. It is not compatible for multiplication. So this code works fine. Okay, so in this lecture we have learned what is matrix multiplication. We have seen some examples of matrix multiplication. We have also talked about the compatibility of matrix multiplication, and then finally by doing some examples we have devised our own logic for performing the matrix multiplication, and we have implemented the same to get the correct output also. Okay, so that's all in this lecture. Stay tuned.